Hello. In this question, there is a disk and a ring. A disk is of radius r and a ring is of radius capital R. The disk is attached to its to the spring, and the disk starts rotating, which is in rotational motion. Now, first of all, we have to find the moment of inertia of the disk. Okay, moment of inertia of a disk is given by mr square by 2, which is already written here clearly. And moment of inertia of the disk according to the parallel axis theorem will be mr square by 2 plus mr square, which is 3 by 2 mr square. This moment of inertia of the disk mr square by 2 is along the perpendicular axis. Now, अब हम लोगों को क्या करना है, ये वी हैव टू फर्स्ट ड्रॉ दी एफबीडी ड्रॉ करेंगे. एफबीडी में ये एंगल थीटा है बिकॉज दिस एंगल इज ऑलरेडी थीटा. दिस एंगल इज थीटा. कॉरेस्पॉन्डिंग एंगल्स आर इक्वल. Okay. Now, another concept is that take this 90-degree, whole is 180-degree, you will get this angle theta. Now, mv, we can resolve mg into mg sin theta and mg cos theta. Mg sin theta and mg cos theta. This is mg sin theta. This is mg sin theta. Now, according to the Newton's second law, the sum of all forces is equals to mass into acceleration. We have to put this value, this FBD. We have the FBD which we have drawn. We have to just uh, along the x-axis, where is mg sin theta plus kx is equals to mass into acceleration. It is to be noted that why kx because due to the spring is attached to this disk as kx. Now, the point to be noted that it is that the disk is rotating, is a rotational motion. So angular acceleration is given by alpha is equals to a by r. Why a by r? Because the disk is rotating without slipping. So there is one concept that alpha is equals to a by r, where a is a tangential acceleration. Tangential acceleration means there are two motions. When a disk rotates, when a disk rotates, it has rotational motion as well as translational motion. Translational motion is the acceleration, tangential acceleration, which is given to the disk. Now, tangential acceleration is given by omega square into r, where r is the radius of the disk. Now, we have to calculate the torque. Torque is given by torque is equals to I alpha. Now, take the torque across the point across the center of the ring. Take the torque across the center of the ring. Take the torque across the center of the ring, which is, then the distance will be r minus r. Why r minus r? Because r is the radius of the ring, capital R is the radius of the ring, and small r is the radius of the disk. Then the resultant distance will be, r minus r. Now, mg sin theta plus kx is equals to minus r. You put this value in this equations. Now, where kx is x, what is x? X is equals to r minus, where x is the smallest distance which the body travels. X is the smallest distance which the body travels, which is x is equals to r minus r theta. Here, x is equals to r minus r of theta. Why? Because we have already learned that when from the center the distance traveled across the circumference means some small distance is r into theta. Here r minus r theta is the x value of x. We have to put this value here only. And after solving all these equations, you will reach to the final answer, this one. Thank you.